Welcome to the part 4 of this project. Part 4 is a continuation of the part 3, which is now data visualization. So in the part 3, we looked at the basic data visualization. However, here first we want to go to correlation analysis in this particular part 4. So we'll start with correlation analysis. It will form part of our number 9. So correlation is a statistical technique or study of relationships between a dependent variable and independent variable. When we talk about dependent variable, this is a variable that depends on others, which we call the independent variable. While independent variable, these are the variables that can define for themselves, like independent, don't depend on any other variable. All right, now in this scenario, we want to explore the correlation between temperature and ozone. So we'll use the core method in R, and we will call these two variables the air quality clean, and we will call the air quality clean, and we'll call temp, and then we will also call air quality ozone. So we want to check if the relationship between temperature and ozone is linear, and is actually either strong positive correlation or negative correlation, or there's no correlation at all. So it's very, very important for us to note that. So it becomes very important in this scenario. Okay, so we'll now call ozone here, and we'll run this to execute, see the value we'll get. So we have a value of 0.6985. So what does that value tell us? Tell us that, so correlation value usually, the correlation R value usually ranges between -1 and 1. When we have the correlation value in the negative side, say that relationship is a negative relationship, meaning that when one increases, another one decreases, like they are indirectly proportional. And then now we have another scenario where when another one increases, another one also increases, which we call a positive relationship, where our R value ranges between 0 and 1. And so that's what now brings us here. Okay. Now we are still discussing the air quality dataset. Now here we are going to now go ahead, and now we have seen the correlation value. So you can go ahead and just come up with a full correlation matrix of all the variables we have, see how they are correlated, and that will give us number 10, which is full correlation matrix of our dataset, so that we can populate all those variables and how they relate in our data. So we'll call core, which is the method for correlation, and we are calling the dataset air quality clean, because that's the clean dataset. And we are going to use this method of data on how we want to plot our results. So we want to plot our results in, as you can see here, let me execute first and I'll explain. So when I execute my correlation, we see that we have how many columns. We see that we are having a matrix of our values. On a diagonal, we have 1 1 1 1, But on the what we are interested in is the corresponding variable with another variable. For instance, ozone, how ozone is actually relating to the solar radiation, has a correlation of 0.34 83417, which we say this value is between the range of 0 and 0.5, range between 0 and 0.5. So this one makes it a weak positive relationship. So it means the solar radiation also positively affects the ozone. So the increase in solar radiation increases the ozone concentration. And when we go to wind speed, and is actually negative here, so it means that an increase in wind speed indirectly affects the ozone, reversely affects the ozone. So when the wind speed increases, we get a correlation value of negative 0.61244966. In this regard, it means that now when wind speed increases, ozone concentration decreases. Okay, and when we go to and you see it's negative, so this is a negative strong correlation. So it means also that wind speed affects the concentration of the ozone. The same thing also now on temperature, we have 0.6985. This is a positive, meaning that when temperature and solar radiation increases, they increase the concentration of the ozone, while when wind speed increases, it decreases the concentration of the ozone. And when we just look at also the variation between these other variables. However, our variable focus, of course, is ozone, how its concentration, how it's comparing across other important variables like the solar radiation, the wind speed, and the temperature. But we can also look at other variables, like for instance, how does wind and temperature vary? So you have to check wind and move up to until you see temperature. It means there's a negative correlation, meaning that when there is wind, there is likely the temperature. When wind speed is high, means the temperatures will be low. And this is the kind of relationship that exists between the wind and the temperature. When you look at the solar radiation and the temperature, there's a strong positive, is a weak positive. Is actually when you look solar radiation, you look rows against column for temperature. 0.2940 indicates that when solar radiation increases, temperature also increases. But however, is a weak positive relationship. So this measures the strength. Correlation gives us the strength of our relationships between the variables that we are in this regard, for our study in the data quality data set. So for more better visualization, we are going also to plot another visual, but we need another library which is called core plot. So you'll try to plot a core plot, and this one is going to be core plot, and we are going to load this. If you don't have this, you'll have to install it in R. I'll take it up there, so I'll run. You see, I don't have this package in the library, so I'll copy this and put it up here so that we can have a consistency between these respective variables. So I just go ahead here and install. So some of the variables that you'll need to install, some of the libraries you'll need to install in this particular dataset. You have seen here you were to install, if you didn't have this library, this variable, this package, none, yay. And then now we can also be able to install. For me, I already have the first one because that is able to execute this one in the part one. And now in this part two, we need to load core plot. So we need to load core plot, correlation plot package, and of course you have to put in quotes. And once I run this and rerun my library loading, so it will now be able to load the library successfully. So it's supposed to install the package here, and so you can see it's doing the installation. And so once we proceed here, we can be able to see once it's finalized the installation process. We'll be able to see some of these changes happen here, and successfully unpacked. So we are good to go. So we can now run this script to load the library. So this will be able to load the library and successfully load the library. Okay, has successfully loaded the library. So we can proceed and now do the plot using this particular package. And the package here is of course core plot, and we now call the correlation matrix, which we already have here. Actually, this script is here, so we can copy just the correlation, this one here, the correlation matrix. So we can plot this. We can just copy that and paste here inside this core plot. And once we have this, we can give a method that we need to use in terms of this visualization. And here I'll give circle. So this is a method for this core plot. So you can just plot that, and you can see that now we have a nice visualization from this particular data set. So it has given us here a very nice visualization that actually you can tell how the relationships are between these different variables. So the more the blue color means that that's approaching 1, but of course this is diagonal. So you look at other variables that have strong relationship, like temperature has a very big positive relationship with the ozone. And you can see wind, this is a negative, strong negative relationship with the ozone. And you can see this one also slightly weak but positive relationship. You can check wind and solar, slightly negative relationship. When you compare some of these, of course, things you can look at even the charts. Your charts also are telling us how these things relate. So what we can do here, if you want to save this, you can just go to export, save as PDF, and then you can save this visual where you want to save it. So if you say save as PDF, rplot core correlation matrix, air quality, so something like that, you can save your visual. And okay, you can just view it after saving, and so you can locate where you want to save in your own directory. So you can choose where you want to save this particular file. So for me, I'll go ahead and save in my R. So I'll go ahead and save in my R project, this one. So I'll save in there. So I'll save here. All right. So now this is opening my visual. So here is the visual. I actually saved it as a PDF, but you can save it as an image, so it becomes easier for you to work with it in other datasets. You can also export this as an image. Yes, and you can save it also just there, and just save it. Also have the image with you. All right, so this becomes interesting that you can see well visualize the relationship. Okay, so it becomes very, very, very informative. Okay. Now let's go further. And we have seen that those relationships, they are positive and negative, and we have already explained that. So let's try to plot a monthly air quality trend. So we want to plot a monthly air quality trend. So I'll come here and plot this one here, monthly air quality trend. And let's have this in the next part, which will be part 5 of this program. So we are now going to do some monthly air quality trend. So this one has been on the correlation matrix, and see you in the next one. Thank you.